Hi, this is Mr. Max with Sankofa Mathematics. So I got a few questions from some students that I quickly want to explain. So this is like your revision work, exponential equations. So some equations, you have an equal sign. You've got things that have got some awkward um, minuses and pluses and so on. So those exponents of the basis there, this is basically what we are going to try to solve. Right, so the objective would be that you somehow come up with a step so that you know what is the first thing that I need to do. So when you look at question A, you realize there are two terms to the left. So it would be wise if somehow we can change these two terms to be one term. Okay, so the same applies with B, but then you have got 3 to the x, which is on the other side of the equal sign. Perhaps if I bring that 3 to the x over, it will create two terms and I'll have something similar like what I had in A. The 2 over 3 is nothing just but a number, like the same that 24 is a number. Here I've got some base, which consists of expression, but it's raised to a power, which equals to some number. So the objective is to get rid of that 5.3. Okay, so let's start with the first one here. So we are going to split. So what I'm doing here, I'm introducing a sort of a split rule that 3 raised to the power of x minus 2 is the same as 3 to the power x times 3 raised to the power of negative 2. I still have two terms on this side. So when I take out the 3 raised to the power of x, you see I've color-coded so you can realize that if I multiply back 3 to the power x times 1, I get that 3 to the power x, that one in black. And you multiply this 3 to the power x times that number, you're going to get that number that you had on top there. So now I have got some value 1 minus 1 over 9, which is what this 3 raised to the power of negative 2 is. That is 8 over 9. And I get then rid of that 8 over 9 by multiplying throughout by 9 over 8, the inverse of that, giving me 27 here. And from this point on, I believe that you know what to do. You would realize that 27 can be written as a base of 3, which is nothing but 3 raised to the power of 3. And if the bases are the same, we drop them and then we only equate the indices, which is the value that we were supposed to calculate from the onset. So again, this one here, I am changing the 3x plus 1, I'm splitting it to 3x times 3 to the power 1. And I brought that 3 raised to the power of x over so it can come and sort of meet its friends on the side, if one can say that. And then I go back and I factor out the 3 raised to the power of x because it's like they are there. So if that concept is a little bit confusing, think of when you are here, think of something like this. When you are doing algebra, you're told that you should factorize these two terms. Now, taking out a common factor here will be x, which is now similar to what I've done here with my 3 raised to the power of x. I extracted it, I pulled it out. And then I'm going to be left with y minus, and you guess it, 1. Because that x and multiplying it back gives you that. So this minus 1 is similar after I extract that 3 raised to the power of x. So it's the same sort of condition. It's just that we are dealing here with some exponents. So don't be too much afraid. Don't beat yourselves up. The method still applies. It's still useful. Okay, so to continue this, then 3 raised to the power 1, which is just 3, minus 1 gives you 2. So first you get rid of that 2, since 3 raised to the power of x is being multiplied by 2, so you divide both sides by 2. And 2/3 divided by 2 is nothing but 1 over 3. And 1 over 3 can be written as a base of 3. It's 3 raised to the power of negative 1. Okay. And then x is obviously going to equal to negative 1. Right, so then part C, again, as I said, the objective was first, let me get rid of that power there, 5 raised to the power of 3. I multiply that by its inverse. Because when you say 5 over 3 times 3 over 5, you're going to get 1. So that means that bracket then is just going to be now minus 1 minus 18 cubed. And then I also changed 3,125. I wrote it in prime factor form and it becomes 5 raised to the power of 5. And when I multiply that power of 5 times 3 over 5, I'm left with 3. And 5 cubed is 125. Taking that minus 1 becomes a positive 1 here. Then I get 126. Then I divide throughout by negative 18. And q should equal to negative 7.